welcome you all to session 2 of the chapter Motion in a Straight Line. In this session, we will be learning about speed, velocity and acceleration. The first concept what you need to know here is about average speed and average velocity. Before I go with the average speed and average velocity, you need to understand what actually the difference between speed and velocity. In the last session, we discussed about path length and displacement. If you know what is the difference between path length and displacement, definitely you can understand what is the difference between speed and velocity. Let me take an example and let me explain you what actually is the difference between speed and velocity. Speed and velocity, right? Okay, you want to travel from Hubli to Delhi by flight, but you don't have direct flight from Hubli to Delhi. So you need to travel from Hubli to Bangalore first, then you need to catch a flight from Bangalore to Delhi, right? Okay, let me take, you want to travel from Hubli to Delhi, but you don't have a direct flight. So first you go to Bangalore, then you take another one flight and go to Delhi. Which is your initial position? Hubli, right? Hubli is your initial position. Which is the final destination? That is Delhi here, right? Okay. If you go by flight, the air distance from Hubli to Bangalore is about 400 kilometers. From Bangalore to Delhi, it is about 1800 kilometers. The air distance between Hubli to Delhi, right? If you have direct them here, right? From Hubli to Delhi, it is about 1500 kilometers. Okay, let me take this later. First, do understand what is path length. What is path length? So the path length is the total distance traveled by a body from initial position to final position. What is the initial position? Hubli. What is the final position? Delhi. So what is the total path length? Total path length is 400 plus 1800. So you will be getting with 2200 kilometers. So what is this now here? Path length. Right. If I want to calculate what is the displacement. What is displacement? Displacement is the shortest distance between Hubli and Delhi here, right? So if I am calculating what is the shortest distance, if I calculate what is the shortest distance between Hubli and Delhi, and it came to be 1500 kilometer. 1500 kilometer. 1500 kilometer. Do you understand? Always path length is greater than or equal to displacement. Path length will be equal to displacement when a body travels in a straight line, right? Okay. So this is path length and displacement. If I travel from Hubli to Bangalore, then to Delhi in 2 hours, right? I took the time 2 hours to travel from Hubli to Bangalore and Bangalore to Delhi. So what is the speed? Do remember, this speed is always related to path length. Do remember, speed is always related to path length and velocity is related to displacement. Velocity is related to displacement. Do you understand? Right? I already told you that in day-to-day life, we follow path length more than the displacement. In the similar manner, here also we use speed physical quantity more than that of velocity. Right? So what is speed? Speed is the ratio of, the speed is the ratio of path length to the time taken. Path length to the time taken. Speed is related to path length. So what is the formula for speed? Path length divided by time taken. I already told you that path length can also be termed as distance travelled. Both are nothing but the distance travelled divided by time taken, right? It is nothing but path length divided by time taken. Can I calculate what is the path length here? The path length is 2200. How much time does it take now here? 2 hours, right? So this is a kilometer, right? So what is the speed now here? Speed is 1100 kilometer per hour, right? If I calculate it, I got 1100 km per hour. This is speed, right? What happens if you want velocity, right? Whenever, if you want velocity, velocity is always related to displacement. Displacement divided by time taken, right? So displacement divided by time taken. So if I want to calculate what is the displacement, so this is initial, final, take the shortest distance, right? If the shortest distance is 1500, right, 1500. So again, we take a to travel from Hubli to Delhi, again 2 hours itself. Then what is the velocity? Velocity is 750 kilometer per hour. Means speed depends upon path length, velocity depends upon displacement, right? Again, this speed does not have any direction, right? You can travel anything again, but velocity, yes, it has direction. It has the direction from initial position to final position, right? It has the same direction as that of displacement, right? So do remember, velocity depends upon the displacement. So I can say like this: speed is a scalar quantity, velocity is a vector quantity, right? Always when we speak about speed of light, right, we can use velocity of light also. Why? Because light travels in a straight line. So whenever a body travels in a straight line, you can use either of speed or velocity, right? When a body travels in a straight line, both are nothing but the same here, right? But if it changes the direction, there is a lot of difference between speed and velocity. Speed depends upon path length, velocity depends upon displacement, right? So do understand what are the difference between speed and velocity, but the SI unit remains the same, right? So meter per second, this is also meter per second. Dimensions also remains the same. But do understand what actually the concept is, right? So what actually the difference between speed and velocity, right? Okay, so this was just introduction about what is speed and what is velocity, right? You need to study about average speed and average velocity. Let us understand these two in detail now here, right? So what is average speed? What is average speed? So do remember, whenever we take about the average, we speak about total, right? Okay, so let us take like this: the average speed is the ratio of total path length to the total time taken, right? Exactly. Here we know that speed is the ratio of path length divided by time taken. If you take ratio of total path length to the total time taken, then that quantity is called as average speed, right? So we know average speed is total path length. So you need to calculate the total path length to the total time taken, For example, if you want to go from Hubli to Delhi, if it takes 1 hour to reach Bengaluru, and from Bengaluru to Delhi, if it takes 1 hour, so this is the total path length here, right? Sorry, it is the total time taken. 1 hour to what we say here, Bengaluru, and Bengaluru to Delhi, if I take 1 hour, so this is total time taken. So what is total path length? Right, I already calculated it. So 400 is the distance from Hubli to Bengaluru. From Bengaluru to Delhi, it is about 1800. So we got 2200 divided by 2. This is how, right? Total path length divided by total time taken. So this speaks about what we say here, average speed, right? So simple. What is average speed? It is the ratio of total path length to the total time taken, right? Okay, next. What is average velocity? It's simple, right? I told you the difference between average speed and average velocity is that in place of path length we have displacement. It does not depend upon path traveled. It does not depend on how the body travels, right? It just depends upon initial position and final position, right? So it is the ratio of displacement, right? It is the ratio of displacement to the total time taken, So this is average velocity. So what is average velocity? It is the ratio of total displacement, or simply you can write displacement, right? Because it does not depend upon how you travel. It just depends upon initial position and final position. So let me take displacement divided by total time taken. Instead of writing total displacement, you can write only displacements, right? So displacement divided by total time taken gives what we say here, average velocity, right? So just if you know the difference between path length and displacement, definitely you can understand what is the difference between the speed and velocity. So do remember, the speed and velocity, let me write in two terminologies. One, let me take average speed and average velocity, and another one is instantaneous speed and instantaneous velocity. Right? We have two parts here. So this is the first part, that is average speed and average velocity. Right? Okay, let me write a formula for this now here. Right? Let us consider there is a car now here. Right? So this car is at a distance x1 at time, what we said here, t1, right? At, for example, 3 o'clock, the car is at distance x now here, right? At 3:05, right, this travels to a certain distance now, right? It travels through a certain distance. Let me call the distance as x2, right? So that too, at a time, what is the time now here? Let me call it as t2. Now, if at time t1, at 3 o'clock the bus is here, at 3:05, after 5 minutes, the car is at this position here, right? That x2. Now, I want to find what is the formula for average, right? Let me take it. It is traveling here. Let me write what is the formula for average velocity. The formula for average velocity. So, what is average velocity? See, do remember, average, it is denoted by V bar. Do remember, whenever you write a line on a physical quantity, understood, it is we are speaking about the average. This is V bar, average velocity, that is equal to total displacement. Means, shall I take like this? x2 minus x1, right? That gives the distance now here, right? So that is, what is the distance now here? x2 minus x1, right? So what is the total time taken now here? That is 5 minutes, right? You know, if it starts from 3 o'clock and if it is at that position at 3:05, then what is the total time taken? 3:05 minus 3 o'clock. So how much do you get now? 5 minutes, right? So shall I say like this? T2 minus what we say here? T1, right? So do remember, how did I take this x2 minus x1? Do remember, distances are always measured from a reference point. If I take this is the reference point, there is a pole here and that is the reference point, right? If this distance, right, if this distance is about 10 meters and this distance is about 50 meters, then what is the distance traveled by the car now here, right? So that is 40 meters. How did you get that? 50 minus 10. That is what I have written, x2 minus x1, right? This is the x2 and this is x1. Do remember, distances are always measured from the reference points. That is why I have taken like this, right? Okay. Now, x2 minus x1 divided by t2 minus t1. Okay. Do you understand now? Let me write V bar. What is V bar? Average velocity, right? So what is x2 minus x1? x2 minus x1, I can write it as delta x divided by t2 minus t1. Let me write it as delta t. Do remember, usually we use delta for difference. Whenever you find difference, we can use this symbol called a delta here, right? So what is V bar? V bar is equal to delta x divided by delta t. So what is V bar? It is about average velocity, right? So V bar is equal to delta x divided by delta t. So this is the formula for average velocity, right? And do remember, velocity depends upon displacement, right? We know that velocity is a vector quantity because it has direction here, right? As it is a vector quantity, it can be positive, negative and zero. First, let us check it out. When is velocity positive here, right? Okay. Now, let me write like this. Velocity is positive, right? Let me write like this. Velocity is positive, right? Velocity is positive. When is velocity positive? Velocity is positive if displacement is positive. If displacement is what we say like positive, right? Velocity is positive if displacement is positive, right? So do remember, velocity is when is positive if displacement. I already told you, displacement we have discussed in the last class. Displacement, when is displacement positive? I told you, if there is a bus stand, you consider the distance from the bus stand towards east as the positive. If it is behind, let me take it as negative. If the car is moving in the direction, if the car has crossed the bus stand, you can take that velocity as positive velocity. Why? Because displacement is positive. Means velocity depends upon the displacement. If displacement is positive, velocity is positive. Means if a car is crossing bus stand and it is moving forward, means displacement is positive. Means if I speak velocity of that, the velocity is positive. Right? Do remember, velocity is positive if displacement is positive. Right? Okay. Now, when is velocity negative? Let me take velocity is negative, right? Velocity depends upon displacement. If displacement is negative, right? Simple. Velocity is negative. When is velocity negative? Velocity is negative when displacement is negative, right? So I told you, if you take this is the bus stand, and if you take the forward distance as the positive, if it moves in the backward direction, right? If a car moves in the reverse direction, right? If a car moves into the city here, right? If I am taking this as positive, this must be negative, right? If the displacement is negative, then the velocity is negative. Means velocity depends upon the displacement. As velocity is a vector quantity, it can be positive, negative or zero. We discussed when is positive and when is negative. Now let me write when velocity is zero, right? So velocity can be zero, but speed cannot be zero. Do understand this? Velocity is zero if displacement is zero. If displacement is zero. What is the meaning of displacement is zero? If a body travels and comes back to the same position, then what is the displacement? Zero. Or if a body does not travel itself, then what is the displacement here? Zero, right? So if a body travels and comes back to the same position, then the displacement is zero. If displacement is zero, then what about velocity? Velocity is also zero, right? Do understand? Velocity depends upon displacement. If displacement is positive, velocity is positive. Displacement is negative, velocity is negative. If displacement is zero, velocity is zero, right? So this was all about average speed and average velocity. Next, we will be learning about instantaneous speed and instantaneous velocity. Now, let us understand about instantaneous speed first, then let me move on to the instantaneous velocity. Okay, what is instantaneous speed? So we have understood about average. Now let me move on to the instantaneous. What is instantaneous speed? What is the meaning of instantaneous? Instant means at that time, right? So whenever we speak anything at a particular time, we speak the word called instant, right? You have heard the word called instant coffee. Means what? You can prepare at a particular time here. You can prepare it quickly, instantly, right? So instant means at a particular time. So what is instantaneous speed? It is the speed of a body. Speed of a body at a particular instant of time. At a particular instant of time. Right? Simple. Speed of a body at a particular instant of time, that speed is called as instantaneous speed. Right? Okay. This instantaneous speed you get when you are traveling on a bike now here, right? For example, a car or a bike, whenever you are traveling, it gives what is the speed at a particular instant, right? If you are traveling, if you see the speedometer of the vehicle, it shows 50 km per hour, means you are traveling with a 50 km per hour. If you increase the acceleration, if you increase the accelerator, right, the speed increases, and again the speedometer also increases. Means what does speedometer gives? It gives instantaneous speed. Means it gives speed at that instant, right? It does not calculate about total distance traveled, total time taken. It will not do anything. It just says what is the speed of the vehicle at that time, right? That speed is called as what we say here, instantaneous speed, right? Speed of a body at a particular instant of time, that is called as instantaneous speed. In the similar manner, what is instantaneous velocity? Instantaneous velocity. Okay. What is instantaneous velocity? Same. It is velocity of a body, right? It is velocity of a body at a particular instant of time, at a given instant of time, at a particular instant of time. So that velocity is called as instantaneous velocity. For example, if a bus is traveling from Gadag to Hubballi, right? If it starts the journey at 4 o'clock and it will reach at 5 o'clock. So what is the speed of the bus at 4:15 if I ask like that? So exactly at 4:15 what was the speed of the bus? That speed gives what we say here, instantaneous speed, right? So it is the speed of a body at a particular instant of time. Similarly, velocity of a body at a particular instant of time is called as instantaneous velocity. Means we are reducing the time to a particular minute now here, right? For example, let me write it mathematically. Let me write mathematically. Mathematically, what is the formula for instantaneous velocity? Right? What is the formula for instantaneous velocity? Instantaneous velocity, it is denoted by V. Do remember, average velocity, it was denoted by V bar, right? We call it as V bar, and instantaneous velocity simply is denoted by V. Okay, come on, tell me, what is instantaneous velocity? Do remember here, I told you, the bus starts now here, right? If I am taking now here, this is if you are traveling in a car from Gadag to Hubli, if you start at 4 o'clock and you reach at 5 o'clock to Hubli now here, right? 5 o'clock to Hubli. If I ask what was the speed of the car at 4:15, right? What you will do? You are reducing the time. Earlier, what was the time? 1 hour. Now it is reduced to 1 minute. Means you are reducing the time in a such a way that the difference will be equal to 0. Right? Come on, tell me, what is the difference between 4 o'clock and 5 o'clock? 1 hour. Right? If I ask at a particular time, the distance is reducing to 0. Means this, if I speak, it is about average. At a particular time, if I speak, it is instantaneous. Okay, shall I write the formula for that now here? Let us check it out. What is the formula for instantaneous velocity? Instantaneous velocity, I will be using word called limit. You will be learning, because I am limiting. What I am limiting? I am limiting the time, right? Limit of average velocity. What is average velocity? Delta x divided by delta t. Right? What is delta x by delta t? That is average velocity. Right? I took first average velocity, and I am reducing the difference in such a way that delta t tends to 0. The difference tending to 0 now here. Right? So what is instantaneous velocity? It is nothing but average velocity, but the delta t time interval tending to what we say now here, 0. Right? So this is how we can explain the instantaneous velocity. What is instantaneous velocity? It is the limit. Right? You will be using this function in mathematics now here. Limits. You will be learning much more in detail in mathematics now here. Right? So what is instantaneous velocity? It is defined as limit of which velocity it is now here. It is average velocity as time interval. What happens to the time interval? Time interval tends to what we say now here, 0. At a particular instant I want. So time interval tends to 0, right? So V is equal to limit of delta x divided by delta t as delta t tends to 0. Then what is this? From mathematics we can write V is equal to dx divided by dt. This is called as differentiation. So we will be learning in mathematics in detail now here, right? What is the dx by dt? That is limit of delta x divided by delta t as delta t tends to 0, right? This can be written as dx by dt. Do remember, in mathematics you have a formula for dx by dt. You can write like this. So what is that now here? Limit of delta x divided by delta t as delta t tends to 0. As time interval tends to 0, you can write this as like this. So what is this? It is the differentiation of displacement with respect to time. So what is this? This is called as differentiation. So this is called as differentiation. Differentiation. What is the differentiation? Differentiation of what is x? Displacement. Differentiation of displacement with respect to time. Right? As I am taking with respect to time, let me take it as dg. Right? Do remember. So you will be learning much about it. When you learn this chapter in mathematics, you will come to know why I have written this formula. So what is the formula for V now here? V is equal to dx divided by dt. Right? So do remember, this is the formula for instantaneous velocity. What was the formula for average velocity? Do remember, average velocity V bar. So what is the formula? Delta x divided by delta t. What is the formula for V? That is dx divided by dt. Right? See the difference now here, right? So this is delta x divided by delta t, total time displacement divided by total time taken. This is at a particular time, right? Whenever I speak about particular time, we can use the differentiation, right? So dx divided by dt, right? Mathematically, I want to say like this: if you differentiate the displacement, you get velocity, right? V is equal to dx divided by dt. In the examination, question may be asked like this: define instantaneous velocity, right? How to define it? Let us define mathematically. Always do remember, if you want to define a physical quantity, you need to explain it by using mathematics. Then only that is the correct answer for what we say here, instantaneous velocity, right? Okay, whenever we write the answer for definition, define, so you need to define it in terms of mathematics now here, right? Okay, let me write in terms of mathematics. Let me write instantaneous velocity is defined as, remember, whenever you use word called defined as, you are writing in terms of mathematics, right? So the instantaneous velocity is defined as, how it is defined as limit of what? Delta x divided by delta t. What is this? Average velocity, right? Limit of average velocity as what happens? Delta t. The meaning of this is tending. There is a lot of difference between delta t equal to 0 and delta t tends to 0, right? So this is exactly equal to 0. This is tending to 0, right? Remember, so whenever we speak about limits, we use the symbol like this. Okay, let me write about this. Instantaneous velocity is defined as limit of average velocity. What is this? Average velocity as delta t tends to 0, as time interval, what we say in a time interval, delta t tends to, what we say here, 0. Do remember, instantaneous velocity is defined as a limit of average velocity as a time interval, delta t tends to 0, as delta t tends to 0. So I defined velocity like this, right? So if the question is asked, what is instantaneous velocity, we can write like this. What is? You can write any answer for this, right? But if the question is asked define, you need to write mathematically. If the question is asked define instantaneous velocity, you write velocity of a particular instant of time. No, it is wrong. So this is the answer for what is instantaneous velocity. Whenever the question is asked define, you need to write mathematically. So define instantaneous velocity. Instantaneous velocity is defined as limit of average velocity as time interval delta t tends to 0, 3 o'clock to 4 o'clock. If I want 3:30, I need to reduce the time interval, and that time interval must be tending to 0. So this is the definition for instantaneous velocity, right? Okay. After learning instantaneous speed and instantaneous velocity, let me move on to the next concept, right? So do remember what is the difference between average and instantaneous, right? Okay. Now let me move ahead with the next concept now here. That is uniform motion and non-uniform motion. Let me take like this: uniform and non-uniform motion. Non-uniform motion, right? When the motion is called as uniform, right? First of all, let us understand about uniform motion. What is uniform motion, right? Okay, let us check it out like this. Uniform, the name itself says uniform motion. Uniform means same, right? Okay, let me tell you what actually uniform motion is. It is a motion in which a body travels equal distances, or let me use the word, a body covers equal distances in equal interval of time. Right? A motion in which a body covers equal distances in equal interval of time. So this kind of motion is called as uniform motion, right? Okay, a motion in which a body covers equal distance in equal interval of time, so that motion is called uniform motion, right? That motion is called uniform motion. Simple. What is uniform? Means if it travels equal distances in equal interval of time, right? If it travels 10 kilometers right? If it covers 10 kilometers in 10 minutes, right? It should cover again 10 kilometers in 10 minutes. If it is so, then the body is said to be in uniform motion. See, a motion in which a body covers equal distances in equal intervals of time, right? So if it covers equal distances in equal intervals of time, then the motion is called as uniform motion. Means the body should move uniformly, right? For example, if you're traveling by a bike now here, right? So you are traveling in such a way that you are never accelerating now here, right? For example, if you are keeping at a 50 km per hour, you should be 50 km per hour. You should never put a brake or never accelerate. If the body moves smoothly, if it moves, right? If it covers equal distances in equal interval of time, so that kind of motion is called as uniform motion. But in day-to-day life, we cannot travel in that way, right? So we need to change the speed now here according to the circumstances. So, if it travels equal distances in equal interval of time, then that kind of motion is called as uniform motion, right? Okay, there is another one type of motion that is called as non-uniform motion, right? Non-uniform motion, just it is opposite of this now here, right? So, it is a motion in which, let me take like this, it is a motion in which a body travels unequal distances in equal intervals of time, okay, see here, a motion in which a body travels unequal distances in equal intervals of time, then that kind of motion is called non-uniform motion. That is called as non-uniform motion, right? A body covers unequal distance in equal interval of time, right? For first hour, right? If it for 10 kilometers, right? If it takes 10 minutes, if the road is smooth, if you are traveling, you are accelerating, and another 10 kilometers, you just travel in 5 minutes now here, right? If you are doing like that, right? So that kind of motion is called as non-uniform motion. Do remember, non-uniform motion is always an accelerated motion. Means you are accelerating, right? If you are moving, you are accelerating, or you are decreasing the acceleration. That is called as retardation, right? You are decreasing the acceleration, right? If the road is not good, you are decreasing the acceleration. Means you are changing the speed here. If you do that, then that kind of motion is called as non-uniform motion here. But what is acceleration? One note point what you need to remember here is in uniform motion, if a body is traveling uniformly, then what is the acceleration, man? What is the acceleration? Do remember, acceleration is 0. Right? In uniform motion, what is the acceleration? Means uniform motion means if you are traveling with the same speed. If you are traveling with the same speed, do you accelerate the bike now here? No. Then what is the acceleration? Acceleration is 0. So do understand. So what is the meaning of acceleration? So it is always related to accelerator. Right? Means you are changing the speed. Right? If you keep same, you are not increasing or you are not decreasing. So that kind of motion is called as uniform motion. So what is the acceleration in uniform motion? The acceleration in uniform motion is 0. Right? Because it does not accelerate at all. It covers equal distance in equal interval of time. If it covers unequal distance in equal interval of time, then it is called as non-uniform motion. You can write the vice versa of this also, right? That is, you can say that it travels equal distances in unequal interval of time. You can explain in that way also, right? So do remember, it travels in an accelerated manner. So this kind of motion is called as non-uniform motion. If a body travels equal distance in equal interval of time where acceleration is 0, so this kind of motion is called as uniform motion. So do understand what actually the difference between uniform motion and non-uniform motion. Now let us move on to the next physical quantity, that is acceleration. So what is acceleration? Let us check it out. The word acceleration comes from the word accelerator in the vehicles, right? If you are traveling, what is the use of accelerator? Accelerator increases the speed or decreases the speed, right? So it changes the velocity of the vehicle, right? So what is acceleration? It is nothing but change in velocity to the particular time here. In particular time, you are increasing the velocity. How much did you increase? Right? So that is, we call it as acceleration, right? If you accelerate the vehicle, means you are increasing the speed. If you are retarding the vehicle, if you are stopping the vehicle, you will reduce the speed. So what do you use? Accelerator. So that is nothing but acceleration. So what is acceleration? It is the change in velocity. It produces change in velocity. Let me call a rate of change of velocity. Means we speak about change in velocity with respect to time. That is the meaning of rate. Whenever I speak about a rate in physics, rate means always it is with respect to time. Right? In how much time does the change in velocity took place now here, right? So that change in velocity with respect to time is called as acceleration. Do remember, acceleration, the use of acceleration is, so why do this concept comes from? Where does this concept come from? Right? It comes from the change in velocity. Right? So the rate of change of velocity is called, the rate of change of velocity of a body is called, what we say here, acceleration. Rate of change of velocity is called acceleration. Do remember, right? For example, if there is a vehicle now here, let me take this is a vehicle, and this is traveling with 40 kilometer per hour, right? And the driver puts his leg on the accelerator and increases the speed. Now the speed of the vehicle, if I am taking the speed of the vehicle, is now 60 kilometer per hour. So what is the change in here? 40 kilometer per hour to 60 kilometer per hour. So there is change in velocity in a particular time now here, right? So this quantity is called as acceleration. Let me take this initial velocity u and this final velocity, what we say here, v, and what is the time taken for this change? Let me take the time taken is t now here, right? So let u and v be initial and final velocities. Let u and v be velocities of the body, right? So in the u be initial velocity and v be final velocity after time t now here, right? Okay, if a body changes, okay, let me write here. If a body changes velocity from u to v, right? From u to v in time, what we say here, t, right? In time t, it changes the velocity from u to v, right? So if a body changes velocity from u to v in time t, then what is acceleration? Let us find what is the formula for acceleration. Acceleration is denoted by a, right? So what is acceleration? Acceleration, the formula is change in velocity, right, divided by time taken, right? Change in velocity divided by time taken. What is the change in velocity? Earlier it was u, now it became v. So what is change in velocity? V minus u, right? Final minus initial, that gives change now here, right? So how much time did it take now here? That is t. So this is the formula for acceleration. What is the formula for acceleration? Change in velocity divided by time taken, right? So u usually denoted by initial velocity, v usually denoted by final velocity by v now here, initial velocity by u. So what is the formula for acceleration? A is equal to v minus u divided by t. So this is the formula for acceleration. And do remember, acceleration, let me take now here, acceleration is a vector quantity. Do remember, acceleration is a vector quantity because acceleration depends upon velocity. As acceleration depends upon velocity, what is velocity? Velocity is a vector quantity. Definitely acceleration must be vector quantity, right? So acceleration is a vector quantity. If acceleration is a vector quantity, right, so acceleration may be, what we say here, positive, may be negative, or what we say here, zero. Yes, vector quantities are always maybe positive, negative, or zero. Now let us check it out. When is acceleration positive, right? Okay, let me write first one. When is acceleration positive? Acceleration is positive. Let me check it out. When is acceleration is positive? When change in velocity is positive, means velocity is increasing. Do you understand? If you are increasing the speed of the vehicle, then acceleration is positive, right? Okay, let me write it. Acceleration is positive if velocity is, what we say here, increasing. If you increase the velocity, then acceleration is positive, right? So acceleration depends upon change in velocity. If this change is positive, then acceleration is positive, right? Acceleration is positive, velocity is increasing, acceleration is negative. Why? When it is negative? If velocity is decreasing, right? Acceleration is negative if velocity is decreasing. Means if you want to stop the vehicle, if you are moving at high speed and there is sudden what we say now here, road break. So what you do? You decrease the velocity. So that acceleration is called as negative acceleration, right? So why? Because acceleration is negative, velocity is decreasing, and negative acceleration is also called retardation. Do you understand this word? Retardation. What is retardation? Retardation is negative acceleration. If acceleration is negative, this word, it is also called as retardation, right? So what is retardation? We are decreasing the speed, right? Acceleration is negative, or negative acceleration is also called as retardation. Let me call like this. If you are increasing, let me call it as accelerating. If you are decreasing, let me call it a retarding, right? So acceleration, retardation. So what is retardation? Retardation is negative acceleration, all right? Okay, do understand this word. What is the meaning of retardation? Okay, now we came to know that when is acceleration is positive and when is acceleration negative. Next we will be learning when acceleration is zero, right? Okay, let me take the third point, that is acceleration is zero. When is acceleration zero? If acceleration will become zero if change in velocity, right? If change in velocity is zero, right? So velocity is not changing at all, right? If it does not change, right? If it is moving with a uniform motion, right? It does not change itself. At that time, what we say here? Acceleration is zero. So shall I say like this? Acceleration is zero if, right, change in velocity. If change in velocity is what we say here? Zero. Or if velocity is constant. Let me take like this, right? Acceleration is zero if change in velocity is zero. That is also correct, but it can also be defined like this: if velocity is what we say here? Constant, right? If you are moving with constant speed, right? So what is the acceleration? Acceleration is zero, right? Acceleration is zero if velocity is constant, or if velocity is constant or zero, right? If the vehicle is not moving at all, right? If it is at rest, it remains at rest. If it is not moving, then what is the acceleration? Zero, right? Because if velocity is zero, then acceleration is also zero. Means when is acceleration positive? If velocity is increasing. Acceleration is negative if velocity is decreasing. Acceleration is zero in two cases. One, velocity is constant, and also when velocity is zero. If the body is at rest, then also the acceleration is zero, right? This was all about acceleration, right? Now let us understand two types of accelerations. As we have studied for speed and velocity, let me write the similar thing for acceleration. For speed and velocity, I told you about two terminologies. One is average speed and average velocity. Then we move on to the instantaneous speed and instantaneous velocity. In the similar manner, we will be studying what is average acceleration and also what is instantaneous acceleration. Okay, let me begin with the first one, that is average acceleration, right? It is similar. If you are perfect with velocity, speed and velocity, then you can write it in a similar manner. Okay, let me take now here, right? So next, let me take about what is average acceleration. What is average acceleration? I already told you that average acceleration is denoted by a bar. When you write a bar on a letter, it is about average, right? What is average acceleration? It is the ratio of change in velocity. It is the ratio of total change in velocity, or nothing but change in velocity, to the total time taken, to the total, what we say here, time taken. Simple. Change in velocity to the total time taken, that is called as average acceleration, right? Okay, so if I am taking, what is the change in velocity, right? If velocity of a body changes from v1 to v2, right? Okay, let me write like this. I told you, if a body changes its velocity, if a car changes its velocity from v1 to v2, this time v1 is initial velocity and v2 is final velocity, in time. What is the time taken here? In time t. What is the total time taken? Let me take it as t here, right? So in time t, right? So what is average acceleration? Let me write here. What is average acceleration? Average acceleration, it is denoted by a bar So what is average acceleration? It is total change in velocity. What is change in velocity? V1 to V2. So what is change in velocity? Shall I write like this? V2 minus V1, right? Okay, let me take it. Change in velocity. If a body changes its velocity from V1 to V2 in the time, right? Okay, so V1 to V2 from a time T1 to T2 now here. Let me write that also, right? From time, what we say here, T1 to T2. Let me take both also, right? Okay, if a body changes its velocity from V1 to V2 from a time T1 to T2, what is change in time now here? The change in time is T2 minus T1, right? So what is that? Is the rate of change in velocity to the total time taken. So what is the total time taken? T2 minus T1. I already told you. If the speed is about 50 km per hour at 4 o'clock and at 4:05 it is 60 km per hour. So what is the change in time? That is 5 minutes. That is 4, 5 minus 4. In a similar manner, T2 minus T1. That is the change in time here. That is total time taken. And what is the change in velocity? V2 minus V1. That is what I have written there, right? Okay. I already told you that how to denote this. Differences are always denoted by delta. So what is the formula for A bar? That is delta V divided by delta T. So do remember, this is the formula for average acceleration. I think you remember what is the formula for average velocity. What is the formula for average velocity? That is delta x divided by delta t. Do remember, the formula for average velocity is delta x divided by delta t, and the formula for average acceleration is delta v divided by delta t, right? So change in velocity to the time taken, right? Total time taken here, right? So delta v divided by delta t. So this is about average acceleration. Now let me move on to the next one, that is instantaneous acceleration, right? So as we already studied about instantaneous, now this concept will be simple, right? So what is instantaneous acceleration? Let me go with instantaneous acceleration. How it is denoted? It is denoted by simply A, right? Instantaneous acceleration, right? It is denoted by A. So what is instantaneous acceleration? It is acceleration of a body at a particular instant of time, right? Simple. Instantaneous means at a particular instant of time. What is the acceleration of a body at a particular instant of time, right? So that acceleration is called as instantaneous acceleration, right? Acceleration of a body at a particular instant of time is called instantaneous acceleration, right? Okay, now let me write this mathematically, right? Now it becomes simple. Mathematically, what is instantaneous? Okay, so let me take now here instantaneous. What is instantaneous acceleration? Instantaneous acceleration. Okay, now we know that. What is instantaneous acceleration? A is equal to, how to denote it? Limit. What you are limiting? Time you are limiting, right? So limit of average acceleration. What is average acceleration? Delta V divided by delta t, as delta t tends to 0, right? So here instantaneous acceleration, A is equal to limit of delta v divided by delta t as delta t tends to 0. This we have seen in case of instantaneous speed and velocity, right? Do remember, I am limiting the average such that the time interval tends to 0, right? Time at a particular instant of time you want. So the time difference is tending to 0, right? How to write it mathematically? We have a concept called differentiation, right? So we have the concept called differentiation. What do you get? A is equal to this. You can write mathematically as dv divided by dt. So dv divided by dt means what? Differentiation of velocity with respect to time. So this is instantaneous acceleration. I think you remember. So once again, what is the average velocity? Delta x divided by delta t. What is instantaneous velocity? Dx divided by dt. In the similar manner, acceleration. What is average acceleration? Delta v divided by delta t. What is instantaneous acceleration? dv divided by dt. Do you understand what is the difference between delta and d? D means at a particular instant of time. Delta t tends to 0, right? That is what this I have written there, right? So you need to understand what actually that these differences are now here, right? Now Let me define this acceleration, right? So this is what is instantaneous acceleration, right? So I need to define what is define acceleration, define instantaneous acceleration. How it is defined? Let us check it out. Let me write mathematically in here. Okay, instantaneous acceleration. Instantaneous acceleration is defined as. It is defined as, how to define instantaneous acceleration? It is defined as, what is LIM? Limit, right? It is defined as limit of what? Delta V by delta T. What is that? Average acceleration, right? Limit of average acceleration as what is this now? Delta T. What is delta T? Time interval, right? Limit of average acceleration as time interval. What is the time interval? Delta T. What is happening to delta T? It is tending to what we say here? 0, and this is the definition, right? So what define instantaneous acceleration? Instantaneous acceleration is defined as limit of average acceleration as a time interval delta T tends to 0. If the question is asked, define, you need to write defined like this. You need to write it mathematically in here, right? So this is called as instantaneous acceleration, right? So we have discussed about what is acceleration, what is average acceleration, what is instantaneous acceleration, right? Now, there is one more concept called uniformly accelerated motion. What is the meaning of this? Let us check it out. Uniformly accelerated motion. Uniformly accelerated motion. Let us check it out. What is uniformly accelerated motion? Right. Okay. So what is this? We know what is acceleration? Change in velocity divided by time taken. So uniform change in velocity divided by uniform time taken, then it is called as uniformly accelerated motion. Okay, let me write. What is this? It is a motion in which the body, okay, it is a motion in which a body changes, equal change in velocity takes place in equal intervals of time, right? Okay, it is a motion in which equal change in velocity of a body takes place in equal intervals of time. Simple, right? We already discussed about uniform motion. In the similar manner, we are discussing about uniformly accelerated motion. What is the uniformly accelerated? If change in velocity, uniform change in velocity takes place in uniform time, means equal change in velocity takes place in equal intervals of time, right? Okay, so here, a motion in which equal change in velocity of a body takes place in equal intervals of time, so that kind of motion is called, what we say here, uniformly accelerated motion, right? So A is equal to delta V divided by delta T average. If equal change in velocity takes place in equal intervals of time, so that kind of acceleration is called as uniformly accelerated motion. The best example for uniformly accelerated motion is, see, if I leave this chalk now here, right, it moves to the ground here, right? When it is moving, the chalk is accelerated. Do you understand? Right? So this is accelerated. How much it is accelerated? It is accelerated due to gravity. That is why there is a word called acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity, and it is denoted by what we say now, small letter g, right? You know what is the value of small letter g on the surface of the earth? That is 9.8 meter per second square. Means if I throw this duster, what is the acceleration of the duster? 9.8. You can throw any body now here, right? If I throw this chalk also, what is the chalk is moving in such a way that it increases the velocity. Just to observe it. Whenever you throw a substance from the top of the building, it will not move with the uniform motion. It will never move here, right? It always move with the accelerated motion. So what is the acceleration of that? 9.8 meter per second square, right? Because the body is moving with a uniformly accelerated motion. Means, shall I say like this? a free fall of a body. If I leave it, it falls freely. The free fall of a body is a uniformly accelerated motion, right? It increases the speed, right? Suddenly, when you throw, it increases the speed, right? And it increases uniformly. How much does it increase? It is 9.8 meter per second, right? In 1 meter. So if it increases by 9.8 meter per second squared. So the uniformly accelerated motion. A free fall is an example for uniformly accelerated motion. Means acceleration is constant, right? What is uniform? That is constant accelerated motion. So a free fall of a body is the best example for that now, right? So the acceleration is 9.8 meter per second. You may throw a duster or you may throw a chalk, the acceleration remains the same, right? The acceleration is 9.8 meter per second square. So this is an example for uniformly accelerated motion. So this was all about acceleration. So we have studied about velocity, speed and also acceleration in this session here, right? Okay, thank you.